Then question number 88, it is 2018 question. You are asked to find the refractive index of glass using a rectangular block of glass and a traveling microscope. A small amount of water, small amount of lycopodium powder and a piece of white paper cut to size of the block are also provided. A letter X is marked in the middle of the white paper. Diagram of traveling microscope that can be used in this experiment is shown in the figure 1. Part A. Identify the parts marked with A, B, C and D. Briefly state their function. A is the fine adjustment knob. We can write vertical fine adjustment knob or fine adjustment knob. We are using it to move a small distance, small vertical distance. Move the microscope for a small vertical distance, or we can get the vertical fine adjustment. Then B, focusing knob. Focusing knob. It is using to focus the microscope. Then C, leveling screws. To level the microscope table. Part D, split level. Verify the level of table, microscope table. Part B, before starting the experiment, while familiarizing with the traveling microscope, a student observed that when the adjustment knobs relevant to horizontal movement was turned, the corresponding vernier scale did move. Give reasons for this. It means fine adjustment knob. When rotating fine adjustment knob, vernier scale did not move. It should be did not move. Give reason for this. Locking knob is not locked. Locking knob, you can identify locking knob in given diagram as F is not locked. In part C, an enlarged figure of main scale and the vernier scale of traveling microscope are shown. Calculate the least count of this traveling microscope. You can identify main scale and vernier scale. For the main scale, we have to get two coinciding points like this. You can identify two 0 points are coinciding, and you can identify that 50th part of the vernier scale is coinciding with upper part. Upper part is 20 millimeters, 24.5 millimeters. we have to get part number. 0.5 millimeter parts, 49. Now we can get x value. X into 50 equals 0.5 into 49. Then x value is 0.5 into 49 divided by 50. Then we can write least count equals main scale reading, main scale division minus vernier scale division. Main scale division is 0.5. Vernier scale division is this one. 0.5 times 49 over 50. Now we can get 0.5 as a common factor. 1 minus 49 over 50. 1 is 50 over 50. 50 over 50 minus 49 over 50 means 1 over 50. Divide by 5. 10 divided by 5.1. Then 0.01 millimeter is the least count. Then part D. What is the adjustment you perform on the eyepiece before starting the experiment? We have to focus eyepiece lens to see cross wires clearly. Then we can write answer for part D. Focus the eyepiece to see cross wires clearly. Then part D, now you are asked to place the given piece of paper on the stage G of traveling microscope and obtain the first measurement with the microscope using the mark X before placing the glass block. Write down the main steps in experimental procedure you would follow achieve this. First of all, we have to unlock the microscope. Then move the microscope to see mark X on the paper. Then again lock the microscope. Now we can see mark X, but it is not clear. Then we have to focus microscope to see X clearly. Part F, relevant positions of the main scale and vernier scale corresponding to the measurement mentioned in part E above are shown below. Write down the reading corresponding to measurement in centimeters. We have to consider given diagram. Main scale reading is, it is before vernier 0. You have to identify, not magnified one, given original diagram. And you have to observe main scale reading by using it. Main scale reading is 4.65. Then we can write reading equals main scale reading plus least count into coincided vernier scale part. Main scale reading is 4.65. It is centimeters. Then you can get millimeters, 46.5. Plus least count is 0.01. and you can identify coincided part using the magnified one. It is 42. Then you have to simplify 46.5 plus 0.42. It is 46.92 millimeters. Part G. After taking the measurement mentioned in part T above, write down the important steps in experimental procedure to the other two measurements that you need to perform. Now we have to find the refractive index of glass block. I will explain that how to obtain it, but it is not in the measuring instrument lesson. It is related to optics lesson. We can coincide, we can focus point X in the paper. Then we have to place the glass block on the paper, and again we have to focus the microscope to the point X. Now we can observe that there is a displacement, apparent displacement of the point X. Then we can get this difference is the then we can get third reading. We have to put lycopodium powder on the glass surface, and then we can focus lycopodium powder again. Now we can obtain, I will consider this reading as T1, this one T2, and this one T3. Then we can obtain T3 is this height minus this one. T3 minus T1 is the real depth. Real depth means height of the glass cube. And then we can obtain this difference between this height and this height. T3 and T2. T3 minus T2 is apparent depth. Apparent depth. We can calculate refractive index by using real depth and apparent depth. Now I will not write steps because of it is corresponding to optics lesson. Part H. Readings of relevant three measurements obtained by another student when performing this experiment are given below. Using the measurement, calculate the refractive index of glass. We can get this relationship, and there is another relationship. Refractive index is real depth divided by apparent depth. We can obtain real depth. T3 meaning is 7.206 centimeters minus 4.606. Apparent depth is 7.206 minus 4.606, and we can simplify it. We can get it approximately 1.52 refractive index of corresponding glass type.